Hi, I'll start this by saying, wherever you are, I hope you're having a great day. So, last time I spoke about how there's like a missing middle that I had identified between like structured data and then like the data that you can have surface to you as a user. And I talked about the semantic web. Here I have kind of like a related idea, but here the missing middle is not actually like the data that we have, but how we actually use large language models and how we use like a lot of different like AI systems and search engines. And I won't be delving into ethics just yet. I won't be delving into like data privacy just yet. I'm just talking about strictly the technology. And one thing that has those, like, one thing that makes my curiosity start to spin is this missing middle, but now it's with regard to, like, we have search engines on one hand, and we have, like, large language models on the other hand. And it seems like there's a missing middle in that we don't really have like a system that I would imagine like normalizes all of the world's knowledge into a, you know, a huge graph of entities and relationships between those entities. And the reason I think it's so weird is I'm always talking about this, so I might have even mentioned it in a previous episode, but it's pretty peculiar that we try to use large language models to store factual data. And it's peculiar, especially because we know that facts change over time, and we also know, and like everyone in the research world has known that like it's pretty unsustainable to retrain a large language model every couple of months to update it with the factual knowledge of the world. And we have lots of like examples of this, but one thing that I think is pretty like telling is the fact that like immediately when these large language models started to hit the forefront, there was this event where Steve Wolfram of Wolfram Alpha fame, he was like, "Oh, these things lie? Okay, just attach Wolfram Alpha to it, and now they won't lie, because Wolfram Alpha will be like an information retrieval tool, and you can get factual information from this." And so we've understood that large language models are not going to be like retrained every couple of days or whatever. But the solution seems to also have its own like interesting aspects, because to my knowledge there has not been any like formal studies that confirm like for absolute sure that with like presented with the factual content, language models definitely won't lie. Like, I haven't seen any like theoretical or empirical evidence in a research paper to suggest that like lying is completely eliminated. And depending on how frequent lying happens, and by lying, I'm referring to what other people would call like hallucinations. And I also recognize that like calling it lying is kind of a not personalization. It's a personification of the system that's like not confirmed to be sentient. But I think lying is the part that I'm concerned with. Like, nobody complains when these large language models tell the truth. And when I say nobody complains, what I mean is kind of like nobody's saying it's a bad thing that they're telling the truth. Like, we generally as a society like prefer that truth gets out and not lies, right? And one of the things that like I read in this like Hacker News post was that everything that a large language model outputs is a hallucination. And like on one hand, that's like funny, and on the other hand, you have to kind of take it seriously a little bit, because to the model, there's no difference between telling a lie and then telling the truth. Or instead of saying a lie, I can just say falsehood. Like, there's no difference between telling a falsehood and telling the truth. And so, getting back to what I was saying, when we had like these large language models and people were like, okay, it's outputting these false statements, people said, okay, let's give it factual knowledge as an input, and that will reduce the proportion of time that it will tell a falsehood. However, I think unless there's any like empirical or theoretical evidence that says it won't lie, we are still compelled to fact check every single thing that the large language model outputs. So we're kind of stuck. And like another property that's like really interesting is that when something is output from like a large language model, we generally like attribute, just because there's no source information attached to it, we generally seem to like attribute that to like OpenAI themselves. Like there were cases where OpenAI themselves were getting sued for an output of chatgpt, which on one hand is like really interesting, because chatgpt, like when you're using the tool, it says, hey, there's a chance that it'll state false things. And I think the lawyers are well aware of the fact that they've disclosed that it's not meant to be a source of truth. But when it comes to like saying like slanderous or libelous claims, like your reputation can still be harmed even if, you know, a large language model is the source of the claim. So it's almost like some part of the editorial process, like the lawsuit is treating OpenAI as a publisher, and the claims are now being attributed to OpenAI rather than the source of the claim. It's very interesting. In any case, what I think all of this means is that there's a missing middle. Like, there is a medium between search engines and large language models. There's a medium where you input a query, the query gets decomposed into a bunch of subqueries, and each subquery is matched with very, very good accuracy to a particular like symbol, like a particular entity, right? So if we did have a knowledge graph of an internet, the question wouldn't be, do you need like a huge large language model? Like, that question wouldn't even exist. If we had a semantic web, there would be no question. Like, it would absolutely just straight up be, oh, who can query the semantic web the fastest? Who can give the most accurate answers as quickly as possible? Right? If we had a semantic web, large language models wouldn't need to exist as they do, except as like a peripheral layer, except as like a very last stage if you want to turn an answer into natural language, right? So instead of staying in this like neural space where it's like vectors and the math is fuzzy and everything is approximate, your query enters the system, and then at each stage, you know the like approximate confidence of, you know, the step that's taking place in the first stage. your query is decomposed into a bunch of subqueries. And then those subqueries are matched to like entities. And we can understand that this matching is a very tractable problem. It's not very difficult to imagine that like the, US president, that term, and the president of the United States of America get correctly matched to their correct entities. They get matched to the same entity. And okay, so if we have that, then it just becomes a graph search task. We don't have like, who is the president of the United States? And the language model that was trained when Joe Biden was president says, hey, it's Joe Biden. Like, we don't have that problem anymore. Like, so then, like, after your query gets encoded into these, like, so you go from like soft, like natural language, to a little bit less soft, which is these like entity identifiers. And then you stay in that less soft, in that more rigid regime until the entire query is evaluated. And then at the peripheral of the system, like after you're done with every hard step of the hard logic and the hard facts, that's when you can decode it back into natural language. And that encoding and decoding I find really interesting because like those are very tractable. Like you can have retrieval augmented generation at the very edge of your system, and it would not take a huge language model, because what the language model would do is very simple, like adding words, adding like determiners where they need to be, and answering the question in the form of a complete sentence. And so the benefit of this kind of a system would be you could attribute it. Like if the web was semantic, you could get an answer to a question and then immediately have all the citations that you could ever need. And so you would be embracing the fact that these large language models like do indeed serve the purpose of search engines. Like then like you could also add in some other interesting steps. Like you can say, oh, I don't have your real answer, but look, here is a similar answer. And then reasoning by analogy, we can obtain this. And then it'll describe the analogy that it's building. It'll map from what it knows to be like a rigid, correct, hard answer. It will confess. It will say, hey, I didn't have your best answer. I didn't have evidence of that. Okay, I'm going to perform this analogy, and it'll translate the whole like response into your answer, and it'll tell you the reasoning it used. Now, analogies are also tractable. Analogies can be solved by word vectors. So if analogies are tractable, and then you can decode them, and that's also tractable, you're taking this one huge intractable thing and you're decomposing it into a bunch of tractable problems with hard, like rigid service level guarantees. And you wouldn't need to train a huge, enormous, like large language model for that. Now, in talking about this, I'm forced to confront this idea that like, what if there really is something with large language models that only can happen when you are at this huge scale? Like what I've been talking about so far isn't like coding. Like coding would not be achievable using this kind of regime. like using this kind of step-by-step decomposition of the query. Um, I don't think it could be. Like, maybe, hey, maybe I just need to think about that a little bit more. Maybe I can just imagine a world where it takes some existing code that already does a similar thing, and then it inserts new code from a different source that does a similar thing, and then it uses the types of the functions, or infers them, and then ensures that those types are also taken care of. And bam, there you go. Now you have something that does what you want it to do. And it didn't require this like intractable step of piping the whole thing through a large language model, but rather was accomplished by just literally like using logical reasoning steps, like composition, like making sure the types check out. And who knows, maybe there's a world where we went that path instead of this one. Maybe there's a world where, literally anyone could get the same amount of like utility out of something that runs on their phone as they do a large language model that runs in a huge data center somewhere. Yeah. So that pretty much like describes my idea. There's definitely bound to be like a bunch of like challenges that I didn't even really anticipate. But there are absolutely things in large language models that are just like a fundamental property of large language models in general that you like that you might not be able to patch out. Like there are some things that are like necessarily not controllable if you just put in, a bunch of data. Like there are just guarantees that you cannot make. Like we don't know if reinforcement learning with human feedback, we don't know if that actually suppresses enough of the thing. We can only observe it. We can't see how it behaves in every single circumstance. What about regressions? How do we know that a later update doesn't re-expose a previously patched out vulnerability? There are some, actual like immutable properties of large language models that will never be addressed except by a fundamentally different system. Yeah, something about the training would definitely, like, I'm not even convinced changing, filtering out some quote unquote undesirable data would necessarily be sufficient. I'm not convinced of that yet. It would take, in my opinion, like a fundamental rethinking of the relationship between the model, the data, and like factual knowledge. And I don't have the answer. I don't want to make it sound like I do. I just know that large language models today have these like fundamental limitations that are, baked into their architecture that you cannot just patch out. And maybe I'm wrong. Like, I have to, like, I think we all have to be a little bit humble when it comes to AI. Like, I think almost everything we say these days has to be prefaced with today, or, like some other forms of qualifiers, like in today's AI, in today's world, for ChatGPT in particular, for large language models in general, today. Like, we have to have those kinds of, like, we have to be humble about this. Because the reality is, like, I don't know as much as the, best human expert in large language models. And even experts are, like, demonstrably they're demonstrably bad at predicting the future. Like, the best human experts can't predict emergent capabilities of AI systems. And it's not even their fault. It's like this whole thing is a black box, and we just don't know the relationship between parameters. And you know, like, there are these people who think that it's like a phase shift hypothesis they have, where they believe that on scaling it that additional marginal percentage, it'll like reach some insanely, surprising thing. And I can't disagree. Like, we don't know yet. We have to face the fact of the matter, which is that nobody knows. It's a black box. We really just don't know. So I would like to retroactively qualify everything I said with this internal dialogue that I should try to say more frequently out loud, which is that everything I said was true of AI as it exists today, except for when I explicitly said, like, I think it's a fundamental limitation of large language models that they're unpredictable. Like, that part, I think, would, yeah, would stand for a while. Yeah, and that's it for today. Yeah, and if you made it this far, thank you so much for listening. And yeah, I hope you have a good one. Take care.